Hi, you guys. In this video, I am going to go over the three or four assessment questions that you had last week. So I'm going to share my screen really quick. This is in Safari. Let's see if it's here. Okay. Now let me try this again. All right, here we go. So last week you had a Google form where you had to go through sort of e-stations in order to understand the life cycle of stars. You also had a PowerPoint presentation that was going to be tremendously helpful for you to understand all of the questions and how to answer those questions in the e-stations and especially the assessment portion. So when we go through this PowerPoint, you're going to see exactly where I got the answers from. So let's start with the first question. It says, where are stars formed? A planetary nebula. B, near the center of the universe. C, a nebula. Or D, a dying planet. So if we're thinking about where stars form, we can immediately say, no, it is not going to form in as a dying planet. That doesn't sound right. And a planetary nebula, that means it has to be forming a planet near the center of the universe, possibly see a nebula. So I took these notes directly from the PowerPoint that you guys had for your notes. And so it says nebula. Interstellar medium begins to collect into big clouds, the birthplace of stars, as stars are made up of gas and dust. It's also called a star nursery. So the correct answer for this question is simply C, a nebula. All right, we're going to go to the next question. What is a black hole? A, is it a collapsed star with gravity so dense nothing can escape from it? B, a cool spot on the surface of a star. C, a cool spot on the surface of a planet. Or D, an area in space where stars are created. Now, from our last question, we already know that the answer couldn't possibly be D, so we can eliminate that answer. B and C, you may think that those are the correct answers if you haven't really read through the PowerPoint, but let's think of this. If you think of a black hole, do you think that it could be on the surface of a planet? Could a black hole be on the surface of Earth? Haven't heard of that before. And because of what we know about black holes, this couldn't possibly happen because a black hole is going to completely suck in anything that it gets close to. That includes a planet. So let's look at our answer. Black holes, and I got this directly from our PowerPoint. Black holes forms when very massive stars collapse at the end of their life cycle. A large area in space with a very strong gravitational pull. Nothing can escape it, even light. So if we look at our answer choices, the only possible answer choice is A. A is the correct answer. All right, next question. Assessment number 3. What factor or factors impacts the life cycle of a star? So I want to bring your attention to this diagram that you saw several times through your Google form. And this is a picture of how stars are born, they go through their life cycle, and they eventually die. If we look at how these stars are grouped, they are grouped according to their mass. So the mass of a star determines what happens to it after living most of its life in main sequence. So the answer to this question is mass. Last question. Assess it, number 4. A low mass star becomes a blank after the main sequence phase. Is it a white dwarf, black hole, red giant, or red supergiant? So if we go back to this picture, a low mass star becomes a blank after the main sequence phase. So if we look at a low mass star, this is when it is formed or born. Protostar is a little baby. Mid-sized star, this is when it is in its main sequence phase, this mid-star. After the mid-star or mid-sized star, after the main sequence, is going to move into this phase. So I got this answer completely from the PowerPoint. Red giant, phase after main sequence. Low and high mass main sequence stars progress to red giants. Outer gas layers of the star expand. As the star uses all its fuel, its core shrinks red in color, and it has a high luminosity. And we're going to learn about luminosity this week. So the answer is a red giant. Red giant is what the answer is. All right, this week we're going to move into the Hertzsprung-Russell diagram. I am going to go ahead and post the video to the form so you can hear from me before you go through the lesson of what to expect this week in science.